-5. Remember, there are 3 forms of linear equations we've talked about this year. This one, remember the point-slope form, which is good when you don't know what the y-intercept is and you have 2 points. Well, actually not 2 points. When you have a point and a slope and you don't know what the y-intercept is, this is a good form we can start with. Then there's the slope-intercept form, which we're very, very familiar with, our go-to formula, because it easily tells us we can easily pick out the slope and the y-intercept from this form. Now, standard form, you're actually going to see more of standard form once you get past Algebra 1 more. But for right now, we're going to just focus on standard form for the purposes of converting it to slope-intercept form so that we can find the slope, because it is not obvious that what the slope of this particular line is from the equation. So we're going to use reverse operations to solve for y and to rewrite this slope-intercept form, as opposed to graphing and finding the bullseye points like we did earlier. In an earlier example, we actually had the graph of the equation in order to find the slope. What happens when we don't have the graph? Well, we can just isolate the y. We can use inverse operation to isolate the y, and once we've done that, the equation will be in slope-intercept form, and we can just read the slope and the intercept. So let's write the equation, and let's begin isolating the y. 3x needs to go. Subtract that from both sides. Let's keep our equal sign straight. And simplifying the left, get rid of the additive inverses, we bring down the 2y. And because 6 and -3x are unlike terms, we can't do anything about those. So what we do discover with 2y equals to 6 minus 3x, we're almost done. All we need to do to isolate the y is to divide by 2, which is exactly what we're going to do. And 2's are going to divide out. 6 divided by 2 is 3, and of course we can't reduce the -3/2, so that means our final answer, our final equation in slope-intercept form is going to be y equals to 3 minus 3/2 x. Since the coefficient of x is a -3/2, then that lets us know what our slope is. But the question is actually asking for the entire slope-intercept form, which we do have. So which one of these looks like that? Hope you chose A, because that's exactly what the answer is. Let's find the equation of the line that passes through the points 4, 3, and 0, 2. The point 0, 2 is a y-intercept because x is equal to 0. So we can use the slope-intercept form to get an equation of the line passing through the points. 2 steps. First step, find the slope. There's the slope formula, and let's substitute into it. Substitute your points in the slope formula and simplify. Get 1/4. Step 2, since we already know the y-intercept is, we already know it's 2, we can immediately write the equation in the slope-intercept form. Y equals 2mx plus b, or y equals 1/4 x plus b. Now I want you to try this one. Let's find the equation of the line that passes through the points 5, 1, and 0, -5. The point 0, -5 is a y-intercept, so we can use the slope-intercept form to get an equation of the line passing through the points. First step was to find the slope. And second step, since you already know the y-intercept, you just immediately write the equation in slope-intercept form. Hopefully you did well. Here's another scenario. Suppose we want to find the equation of the line that passes through the points 4, 5, and 7, 6. Note that neither one of these points is a y-intercept. And since that's the case, we need to use the point-slope form to get an equation of the line passing through the points. So here are the steps. First, find the slope as usual. All right, after we found the slope, then we need to choose one of the points. I'm going to use 4 and 5, 4, 5 because it's smaller, I guess. And then once we have the point and the slope, we substitute into the point slope form. And then we need to simplify after that. Let's see if we need to. We'll see. So if I substitute the 5 for the y1, the 1/3 for the m, and the 4 for the x1, x01, I have my equation, the line in point slope form. I mentioned earlier that you can use the point slope formula in order to find the y-intercept. In order to do that, you need to actually convert it. And you can convert point slope-intercept form with 2 steps. First thing is distribute the, basically simplify it. So distribute the m value or the slope across the parentheses on the right. And then once you've done that, the next thing you do is isolate y. So once you isolated the y and you combine your like terms on the right, you will arrive at the slope-intercept form. And now you know the slope and you know the y-intercept, even though you didn't know either at the beginning. Got one more equation for you to try. Find the equation of the line that passes through the points -2, 4 and -7, -3. Now notice that neither of the given points is a y-intercept. So we have to use the point slope form to get an equation of a line that passes through these points. So step 1, find the slope. Let's substitute our values. And once we simplify our fraction, we get 7/5. Now we're going to choose one of the points. I decided to use the point -2, 4 because there's only one negative to worry about. And then we'll go to step 3, substitute your point and your slope into the point slope form and simplify if necessary. So here's a point slope form. Let's do our substitution. 4 is y1, 7/5 is m, and -2 is x sub 1. Okay, now notice that we're subtracting a -2, but that's the same thing as adding a +2. So we can simplify that last statement like this. And that is the equation of the line that passes through these 2 points in point slope form.